Geometry, Unit 2, Lesson 6. I can write and graph the equations of parallel and perpendicular lines. Why do we want to do that? We've been working with parallel lines and perpendicular lines in 2 and 3 dimensions so far this unit. And we want to know how to do this in preparation for dealing with applications in the future and see how parallel lines and perpendicular lines work on the coordinate plane. So let's get right in here. Our find is to graph the solutions to these equations. I'm going to do one, and then you can go ahead and try one yourself. Our goal here, we can see we have slope-intercept form. You can make a table of solutions, inputs and outputs, or you can go ahead and realize your y-intercept is going to be here at 0, 1, and then your slope is going to be here at 1, 3. So 0, 1, and then this tells me rise over run. I'm going to go up 1 and to the right 3. And then I'm going to do it a few more times. Walk my slope is what I call that. Up 1 to the right 3, up 1 to the right 3. And these are how the vertical and the horizontal change relates to each other. I can also reverse this process. You'll notice if the slope is 1/3, that's the same thing as -1 over -3, because a negative divided by a negative is a positive. So while this is up 1 and to the right 3, this is down 1 and to the left 3. So from here I could go down 1 and to the left 3, and you can see we're on the same line of solutions. Any x, y point on this line, when you substitute it in, makes the equation true. That's why it's a solution. You can go ahead and try the next one. Feel free to press pause and try it. Okay, here I go. I'm going to start at -4 on my y-axis. That's down here at 1, 2, 3, -4. So 0, -4. If you put 0 in for x, you get y equals -4. And now my slope here, -5 over 2. This we need to talk about. If you have the negative out in front like that, I usually just put it in the numerator or the denominator. A negative divided by a positive is a negative, which is why this is the same thing. A positive divided by a negative is also a negative. You get to pick. Either go down 5 and to the right 2, or up 5 and to the left 2. Same thing. I'm going to go up 1, 2, 3, 4, 5, and then to the left 2, 1, 2. I'll walk my slope a few times. 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. Okay, I'm going to go ahead and make this line of solutions. Straight edge would serve me well here. I'm good to go. You can see I went up 5 and to the right 2. So that's graphing our solutions from the equation. Let's reverse the process now. Let's try and write the equation from the graph. So I'll do one, and then you can do one. This is my y, my vertical. This is my x, my horizontal. Let's go find the y-intercept first. Here it is. That happens to be at 0, 1, 2, 3, 4, 5. And let's see if we can find the slope. To do that, we want to look for integer coordinates. So here, I don't know what the coordinates of this point, this point, this point, I don't know what those are. But I think I know the coordinates of that point, of this point, of this point, of this point. So if I were to think about my slope here, it looks to me like it's going up 3 and to the right 1. Or you could say down 3 and to the right 1, which is the exact same thing, your pick. So I'm going to go ahead and write my equation. I'll pick this slope here, up 3 to the right 1, x, and then my y-intercept is here at 5, 0, 5. Again, if you put 0 in for x, you get 5 for y. And that there is the equation of my line in slope-intercept form. You can now hit pause and try the next one on your own. Okay, here I go. Here's my y and my x axes. My y-intercept looks to be here at 0, -1. And my slope, if I can find some points, that looks like a set of integer coordinates, all integers. So I'm going to go ahead and take a look. Looks to me to be about down 1 and to the right 2. So for my equation, I'm going to say down 1 to the right 2, and then it's going to be -1 for my y-intercept. Okay, so let's go apply these ideas now that we already learned in Algebra 1. So, parallel lines. We learned in Algebra 1 that parallel lines have what kind of slopes? The same slopes. And think about that. If you have two lines and the points on them are always moving on the same slope, those lines will never touch. Kind of like two dancers always stepping the same steps. This way they'll never step on each other's feet. So our first task, let's just take a quick look. Which of the following equations is parallel to this equation? So remember, they have the same slopes. So the slope of this line here is 2/3. So I have to find the same slope here somewhere. Well, that's not the same. That's the reciprocal. Close, but not quite. That means this one has to be it, although they don't look the same. But the reason they are is because this one's slope, 4/6, if I break it into its factors, 2/2 is 1. Aha, they have the same slopes. So that's why this is the line that's parallel to this one. Check to make sure they have different y-intercepts as well, otherwise they'd be the same line, and then they're definitely not parallel because they're hitting each other everywhere. Let's go ahead and take a look at a different type of problem. Here, our find is to write the equation of a line that is parallel. So hold on, I need to write the equation of a line. That's my find. I know when I'm done, if I've done that. But I need to be parallel to this given line here, and my new equation has to go through this point. So I'm going to start with the algebraic way to do this, which is really important because if I were to give you rational, decimals, fractions, you just couldn't do the graphing way, which I'm going to show second. So I'm going to start with the algebraic way, and then I'll show a graphing way to do this. So I want to write an equation of a line, and I'm going to choose slope-intercept form, which means I need a slope and I need an intercept. Well, the slopes can be the same because I want to be parallel. So I'm just going to put -2 right there. Don't forget that's -2/1. Now, I don't know what my y-intercept is, and to find it, I need a point that's going to be on my line. This is a point that my line of solutions has to go through. So that has to be a solution, meaning if I substitute it in, it makes this true. So I'm going to go ahead and put 3 for x, so be careful when you put them in, and -6 for y. I'm going to go ahead and solve for b. I simplify this expression, and now I'm going to undo with my inverse operations, the -6, and my b is 0. Therefore, the equation of my line that's parallel to this line and goes through this point is, and you don't need the +0, and you don't need to put over 1. I like to just to remind myself. So here happens to be my slope, which I got right here. It's the same slope. And here is my y-intercept, which I got right here through this process. What happens, though, if you wanted to try and do this by graphing? Well, I can grab a piece of graph paper, and I'm going to go ahead and just copy this down right here. I need to make a line that's parallel to this, and it's going to have to go through that point. So I'll do this one real quick. I'm going to make just a very quick sketch of my xy plane. And well, I need a new equation that's parallel to this one, and it has to go through this point. Okay, well, hold on a second. Let's go plot that point. 3, 1, 2, 3, and down 6. 1, 2, 3, 4, 5, 6. There I go. I have to go through that point. And it has to be parallel to this. Well, what do I know? I know that means same slopes. So that slope right there, I need to use it. And that's really negative 2 over 1, which is down 2 and to the right 1. So what I can do is I can come over here, and I can go down 2 to the right 1. Down 2 to the right 1. Don't forget, though, I can reverse that. Up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. And that's really important because take a look what I just found. My y-intercept. So my y-intercept is 0, 0. And I have the exact same slope down 2 to the right 1. That now allows me to write my equation. Same slope, and my y-intercept is 0. If you think this is a much easier way to do it, you could be right, yeah, if you like it. However, what happens if I did this to you? I'd like you now to go through 3.2 and negative 6.5. Uh-oh. Now this is a big, big problem, right? Plotting 3.2 is incredibly difficult, and seeing, imagine if this line here didn't cross right at some integer coordinates, but crossed maybe right here. I don't know what those coordinates are. So now I can't use this method. So you need the algebra method I did first. However, if you do have everything integer, you can take an attempt to do it this way, hoping that it's going to give you an integer y-intercept. Okay, let's go right back to what we were doing, but let's go after perpendicular lines now. Perpendicular lines you're going to remember from Algebra 2. They're 90 degrees when they intersect, and they have opposite reciprocal slopes. Opposite is like plus or minus. So what's the opposite of 2? Negative 2. What's the opposite of negative 5? Positive 5. Okay, that's opposite. But what's reciprocal? Most people think of reciprocal as flipping the numerator and the denominator. So for example, if you have a over b, well, the reciprocal is then b over a. A quick example of this, though. Imagine I have 2 over 3, and I want the reciprocal. It's 3 over 2. We flip the numerator and denominator. But if you test it, and you do the product, look what happens. 2 times 3 is 6, 3 times 2 is 6, and what do you get? 1. And so one of the ways you know you have reciprocals is if their product is 1. Opposite reciprocal. All right. So if I said to you, which of the following equations is perpendicular? Well, I need opposite reciprocal slopes. So what's the opposite of 2/3? Well, it's going to be negative because this is positive. Well, the only negative slope over here is this one. So this has to be the answer. Let's see if it's reciprocal. 2 over 3, flip it, 3 over 2. So there's the reciprocal and their opposites. If you want to test it, negative 3 over 2 times 2 over 3. A negative times a positive is going to be a negative. 3 times 2 is 6. 2 times 3 is 6. Turns out that's negative 1. They're opposite reciprocals. Reciprocals because they multiply out to 1, but opposite reciprocals because a negative times a positive makes a negative. So this is a good way to know you have perpendicular slopes. Okay, last thing. Again, you can go graph this, take the opposite reciprocal slope, and go find the y-intercept. Or you can do it the algebraic way. The slope here is 1 over 1. When you don't see a coefficient, it's really 1. So what I'm going to do is go ahead. I need a slope and a y-intercept for a line that is perpendicular to the given line here. And it has to go through that point. When I find, I need to write that equation. So I'm going to take this slope right here, but I'm not going to put 1 over 1. I'm going to do the reciprocal, which is, well, 1 over 1, if you flip it. However, notice it's now negative because it's the opposite. I need an x and a y in here to help me find my y-intercept, I'm going to use this for x, because it has to be on my line of solutions. I'm going to use this for y. And a negative times a negative, if we simplify this expression, it's a positive 4. Let's now use inverse operations, and solving for b, it's negative 11. Therefore, the equation of my line, I'm going to go ahead and use negative 1 for my slope, and I'm going to say minus 11 for my y-intercept. So the y-intercept came from right here, whereas the slope, I took the opposite reciprocal of that slope. Plot the point if you really like, and go ahead and take the opposite reciprocal and use that slope to find the y-intercept. Should you want to do this out on paper, it's a similar process to the parallel lines. Good luck.